Actually, this is the final chapter for this course, this semester. Because for this textbook, it consists of I think 40 or 50 chapters. 15 chapters. So it's very difficult to complete in one semester. So this chapter 6, is the design procedure for the hydrostatic bearing. So if you follow the step in this chapter, so you can design a hydrostatic bearing. What I mean is hydrostatic bearing and aerostatic bearing as well. So you just follow the step here. And for the textbook, you can use as a reference because starting from the chapter 7 is planned hydrostatic bearing, so it's a atmospheric design. And chapter 8 is a partial journal bearing. Chapter 9 is recessed hydrostatic journal bearing. And chapter 10 is planned journal bearing. Chapter 11 is bearing. Chapter 12, conical journal bearing. And we have chapter 13, spherical bearing. And then we have chapter 14 for the dynamic the testing, for the dynamic vibration for the hydrostatic bearing. And chapter 15 is the experimental method testing for the hydrostatic bearing. So if you are interested in design and develop the hydrostatic bearing, this is a very good reference book for you. And if you are interested specifically for the aerostatic bearing, in the previous chapter, chapter 5, he mentioned about the design, MTI design handbook for air bearing. Let me show you. So if you are interested in the design of air bearing, this one is good. It's better than this textbook. So this textbook is for hydrostatic bearing. For aerostatic bearing or air bearing, this one is the Bible for the design of air bearing. So if you are interested, you can borrow and make a photocopy from the library. I think in at least two university libraries you've got this book. One is Taiwan University, and another one is yeah, Chengkong University. And two other institutional libraries at this book. One is in the well, Egypt Industry Technology Research Institute. Another one is from Zhongkeyuan. Okay, so if you type this title, we can search the catalog from the library, so we can borrow this book. It's quite a, I think it's more than 600 or 700 pages.所以如果对空气轴承有兴趣的，其实是要去看这个，这本其实是圣经，对，空气轴承设计的圣经。国内是有几家图书馆，如果我没记错的话是台大跟成大图书馆，另外还有两个图书馆，一个是工研院图书馆，一个是中科院图书馆。对，就是 MPI 的那个设计的，它其实是呃工研院的话，我看到的也是一样，他们也是 copy 它就是散装的，用那个 A4的那个夹子，其实是有2本。So this is a very good design handbook for the area. And for our textbook, originally, if you look at the version 1, it's only for the hydrostatic area. And for the version 2, this is the version 2. So the author included the air barrier, but without any further detail of the air barrier formula. It's not clear how we can design an air barrier. But for hydrostatic barrier, it's quite a good book. Right? So this is more or less we mentioned last week for the content of chapter 6. So we start from the design the selection of the design pressure ratio, which means it's the recess pressure divided by the supply pressure. So for the acceptable, usually the acceptable range is PR divided by PS is equal to zero point 0.5. Okay. However, sometimes because you send your technical drawing to the factory to manufacture your hydrostatic bearing, or sometimes the control of the tolerance is not so good, so your film gap thickness is bigger than your original design film thickness. In that case, you need to make some adjustments for the resolution. Okay. So usually you can take zero point 0.5 for the PR divided by PS for the design pressure ratio. But if the gap is too big for your manufacturer, the final film thickness for your bearing, so you can increase a little bit. Okay. And then we have some design procedure for the zero or low speed hydrostatic bearing. So in previous, I think in chapter 3, we discussed about the classification for the high speed bearing and low speed bearing. So it depends on the power ratio. Okay? So you can divide it into the low speed bearing or high speed bearing. I would say most of the case, yeah, 95% of your industrial applications, you are designing low speed hydrostatic bearing. So, so far, I saw only the printed circuit for the drilling machine, the drilling spindle, air bearing spindle for PCB drilling, more than I think 500,000 RPM. In that case, you can consider this a high-speed bearing. Otherwise, you can all classify all the applications to the low-speed hydrostatic bearing. Actually, most of the time you design your air bearing or hydrostatic bearing just according to the low-speed bearing regime is enough, I think. Yeah. Okay. So, and in this chapter, we also mentioned about the dimensional tolerance for the hydrostatic bearing. Um, if you want to follow the ISO standard, there's tolerance specification for that. Overall, for your manufacturing of the hydrostatic bearing or aerostatic bearing, you need to carefully select the manufacturer or manufacturing factory because the dimensional tolerance is very tight. So you should pick one. You should pick the manufacturing factory which has very good quality control for their product. Otherwise, you will have a problem for your hydrostatic bearing. Because sometimes if your final lubricant thickness is too big, then it's impossible for you to just raising the pressure ratio because it cannot cover all the high film thickness. Okay，其实你要选择，如果做静压主轴或静压轴承的模组，厂商的制成能力就是制造精度是最重要的。有时候它的最后组装出来的间隙离你的设计值如果有一点点偏差的话，还可以借着提高这个压力比来调整过来。但有时候间隙实在是太大是没有用的，就是没办法去做调整，其实就只能重做一遍。所以虽然比较好的厂商会比较贵，但是总比你要重做会比较好。So So usually the manufacturer for a good quality of the hydrostatic bearing or air bearing, the production cost is higher. I would say maybe 20 to 30% higher than regular manufacturer. 通常成本会增加个2-3%，所以基本上到最后你会知道，国内就只有几个厂商是可以合作的，其他的基本上都不行。So last week we talked about the design pressure ratio. So regularly we select the 0.5 as the design pressure ratio. But if you have some problem for your design film thickness, so your film thickness is smaller than your design film thickness, so which means that your film, the final film thickness is smaller than your design film thickness. Then you should select a smaller one, okay, maybe 0.4. But if your film thickness is higher than your design film thickness, you need to select the preservation height. 所以其实组装完你才知道最后的间隙是多少，它比你原来设计的时候估算的那个间隙，就是油墨间隙的，如果是小的话，就表示它的刚性会比较大，这时候你就要选设计的压力比较小。如果你发现你组装出来的设计间隙是比你原来预期的还要大，这时候你如果是照原来的风压条件的话，你的枪压一定不够，所以你要去调整它变成比较大的压力。So this is the manipulation for your design refrigeration. Okay. You should select them according to your actual film thickness after final assembly. 所以我们一般正常的话，这个设计的压力都是把它设计成零点五，也就是说油箱压力大概是风压的1，但是如果最后组装出来的间隙不是你的设计间隙，你就可以做一些调整。Okay. So, and another specification for the low speed or high speed hydrostatic bearing is by checking the power ratio, which means that is friction power divided by pumping power. So if the power ratio K is smaller than 1, which means it's a zero or low speed bearing, low speed hydrostatic bearing. 所以我们其实前面已经有定义过，就是压力，不对，功率，功率比其实就是我的摩擦功率比上我的烫补的功率。这个值如果是 K 值如果小于1，就是我们讲的低压或者是零速度的那个轴承。So the design pressure ratio usually we use beta, the symbol beta. Uh, and here we have H naught or HO. It's design field thickness. Okay. So this is because in the beginning when we design a bearing, we need to assume one film thickness, and then you can calculate the performance for these bearings. So such as the low capacity, stiffness, or your volume flow rate. Okay. So you need to have a baseline by define your design film thickness. 所以我们一开始其实 要去评估轴承的话，其实我们就是要给力一个设计的间隙。设计的间隙就是 HNO，但是我们常常是因为加工的时候，每一个零件都需要给工厂，所以我们制造出来、组装出来的间隙，其实不一定会是我的设计间隙。这个才是前面我们为什么我们需要有一些弹性的预注，让它的压力非常的紧，可以是让它调整在到极限。所以如果我的设计间隙，组装出来的最后间隙跟我的设计间隙有点差距，差距不是很大，我还可以做一些调整。所以基本上轴承是枪支这些组装完成之后，我们再依据实际的间距，最后才去选我的压力。我的压力笔选出来，我就知道 PS 到 PR，我要把它压力降多少。我是去设计我的节流器。那对小孔来讲，就是我只是孔径的大小。对毛细管来讲，就是毛细管的长度。我们是调整那个东西。So this is a design procedure for the zero or low speed hydrostatic bearing, which means that this procedure is valid for the bearing as well as the external bearing. So any kind of hydrostatic bearing or any type of hydrostatic bearing can use this procedure. Okay. So you need to select the bearing type. The bearing type is the we talked about last week. Is the truss bearing or joint bearing. Is a full joint bearing or partial joint bearing, or is it a conical joint bearing or spherical bearing? So this is the bearing type. Okay. And you have to design some invariable parameters such as the load capacity or the length of the bearing or geometry of your bearing. So for the geometry of your hydrostatic bearing, usually it was constrained by the dimensional limitation for installation. 所以再来的话，就是我们要决定一些固定的参数，固定的参数可能是，比方说我的这个指挥轴承它要承受的负载是多少，外力的负载或者是它的尺寸，OK，就是它的尺寸，因为我的，比方说我的中继机我要装这个指挥轴，那我的尺寸限制是长宽是多少，所以这些的话其实都可以给你。Here we have a low capacity, the diameter of your journal shaft, the length of your journal, and supply pressure. Usually, supply pressure, okay. And then you have the viscosity of your lubricant here, and the original design film thickness, and also the ratio of the bearing length or bearing speed. 风油边的 So this one we talked about in our textbook is a quarter, 0.25 for your bearing length width. Okay, so bearing length width ratio. And the design field thickness depends on the capability for the assembly worker in your manufacturing factory。所以这个是设计的间隙，油墨间隙，比方说是主轴这些，通常是你的加工厂会跟你讲，我的间隙大概要多少，比较好组装。通常他们大概都是以15分钟以内组装没有什么问题。如果要花超过15分钟去煮那个间隙，比方说我的轴要套到我的轴颈里面，如果是不好套，那我们可能就觉得这个间隙太小，要花很多时间。还有就是我的粘度。So the viscosity of your hydrostatic barrier, the viscosity grade of your lubricant will depend on your operational speed. Okay. Maybe for the spindle is the RPM for your spindle, or for the slide table is the moving speed. 所以这个粘度的话，其实会跟你的运动速度有关。像主轴的转速，我们一般来讲，你如果是1500 RPM 以下，我们可能就是选15号的油，对，或32号，应该是15号的比较多。转速越高的话，粘度要越小，就是要血稀的油，不然的话它会发很高热。粘度越高，它其实也转不快，那个油。所以你选这个the selection of the viscosity grade of your lubricant depending on the operational speed for your hydrostatic barrier. Okay. The higher the speed, the smaller the viscosity grade you should select for your lubricant. Okay. 主轴来讲，通常用的大概就是一般来讲，大概都是5号到15号是比较常用。所以我想5号到15号大概就是3000 RPM 以下。那当然，因为你有直径了嘛，也有长度啊，所以我们就是可以用那个，so if you have the diameter and the length of your jumper bearing, so you can use the design flow chart to understand or to have a briefly estimation of your load capacity. 所以基本上你如果有一些粗略的尺寸，你大概就可以去估算我的油枪大概可以承受多少的负载。那我就可以去考虑一下我的供油压力到底要多少，因为你有尺寸，是不是我就知道那个油枪的面积？You can have some rough estimation for your recess area from its diameter or length of the barrier. Then you can have I would say, rough estimation for your load capacity. Then you will know the supply pressure. 所以通常我们大概从这个尺寸跟油箱之间的关系就可以大概估算我的公压大概要多少。那我也知道我的公压就是我的公压就是 PS， 但是我的 PR 大概是公压的一半。所以从这个例子你可以知道它到底满不满足你的 load capacity， 就是负载条件。So from the dimension of the bearing and from the supply pressure, then you can have a rough estimation for the load capacity. See if the bearing can area and the reset pressure is enough for the requirement of the load capacity. So in this case, we have we can calculate some of the values and parameters from the design chart. Okay? So ethanol. So this was decided from the assembly workers or your manufacturer factory. Okay, and this is very less with ratio. So usually we repeat 0.25 for this one. And this is the pressure ratio. This is the regular one. We keep 0.5. Okay. And this one is the beta is for the hydrostatic bearing. The KTO is for the air bearing. It's the same definition by using different symbols, but it's pressure ratio. Okay. Recess pressure divided by supply pressure. So, right? And then you will know after the final assembly, you will know the actual film thickness. Okay. So usually we keep some range for your film thickness by using this.所以我们大概会用这个方式来看，我最小的油墨间隙跟最大的油墨间隙，最大的油墨间隙大概是最小油墨间隙的1.5倍。比方说我的设计间隙，H 0，一开始我设计我的轴承都是用20 micron 20 mm 来设计。那如果组装出来，它是在这个范围内，20上下，大概上下0.5，其实是还可以，可以做一些调整。那如果是超过1.5倍以上，比方说我设计是20 mm，但是我实际加工出来是40，基本上那个就很困难，间隙太大。即使是你去调整这个公压比，也很难去补偿这个东西。但是我们会尽量把它调高，可能会调到0.8，非常，因为你的间隙变得太大，间隙变得太大，其实就是它的压力不容易积蓄了。大部分因为间隙大就容易把压力流掉，所以通常我们会把公压，应该讲枪压跟公压这个再去做一些调整。And then we have this one. So if, if the final film thickness is equal to the upper bound of the design film thickness. So this is the upper bound, this is the lower bound. Okay. So make some adjustment for that. So 我们是做一些调整。设计间隙如果最后的间隙如果跟我的设计间隙不一样，我要调我的公压。其实我是要保持我的 PR，要让 PR 是跟我原始设计的 PR 是一样，但是我会去调那个压力、公压。 只是我们策略啊，可能是在调整，量出来的实际间隙跟我的设计间隙不一样，就是做一些。So if the final film thickness is different from the design film thickness, so you make some adjustment for your supply pressure ratio, and then we calculate the final performance of the bearing, such as the stiffness, flow rate, the friction power, and the maximum temperature rise. So you need to check if the stiffness is satisfied for your application. 所以你要去看一下它最后的刚性啊、流量、功率，还有最大的升值，特别是刚性，如果是切削工艺机，我前面有讲过，我们的 I mentioned about the thickness of hydrostatic bearing. So the minimum thickness for your bearing design for the hydrostatic bearing. So this is a minimum requirement for your hydrostatic bearing. I mean the limit for thickness for your bearing. For the thickness of your air bearing, it's a bit smaller, maybe 15 in the air bearing. So for most of your applications, you need to check the performance, especially for the cutting machine tool application. The thickness for your hydrostatic bearing should be higher than 200 newtons per micron for the oil hydrostatic bearing. For the air bearing, at least you need to have a thickness bigger than 10 newtons per micron. Okay. So once you have already finalized your pressure ratio, so you have your supply pressure, then you can calculate your flow rate for hydrostatic bearing, and you can also calculate the power, the pumping power and the friction power. Okay? And you can also estimate the maximum temperature. So we have this finalized, which means we already know PS, we already know data. Okay? we know the PS, we know the beta. Beta is equal to PR. Yes. So in this case, this is no, this is no. So we know the PR. Yeah. So then we need to design our restrictor so that you can regulate your supply pressure and change to the PR. So the final step is to design your flow restrictor, design your flow control device. Okay? Because in above mentioned step, you already know the PS, you already know the beta, so you know the PR。所以前面到这边为止的话，我们就把 PR 跟 PS 都决定出来。PR 跟 PS 决定出来了，再来就是我们依照我们的需求，选毛细管节流器或者是小管节流器，让它调节从 PS 变到 PR。So the final step to design your flow restrictor is that you select the capillary restrictor. Is that you design the length, you calculate by the formula. You already know the capillary tube, the inner diameter of the tube, then you can calculate the length so that you can change your supply pressure into your recess pressure. And if we are selecting the orifice restrictor, if the inner diameter of the orifice will decide how you can regulate your supply pressure to the recess pressure. 再来的话就是看你选择节流器，这边的话我们大概讨论的重点就是毛细管跟桥。毛细管其实就是我们的长度，长度越长，压力变化越大。所以如果 PS 变到 PR 是很大的变化，那就是毛细管的长度一定是比较长。那如果两个压力差没有很大，那毛细管就会走动。那这个也是这样，小管节流器的话，就是它的孔径大，所以基本上流程是这样。So this is the basic design flowchart for the low speed hydrostatic gas or low speed capillary design. Low speed or zero speed. Okay, we'll take a break. Thank you. So here you need to be careful here. So if the final field thickness is different from the design film thickness, you need to have some adjustment for your pressure ratio. And after that, you can make some calculation for your stiffness for the bearing. See if the stiffness is fulfilled. I mean, the requirement of the stiffness is fulfilled. So the final step is to design the restrictor. Okay. So from the previous four steps here, you have already decided the recess pressure, supply pressure. Then in that case, you can the next step you can select one type of the restrictor. So usually we will design the capillary restrictor or orifice restrictor. For large bearing, so usually we use capillary restrictor. For small bearing, such as the speed, we usually use orifice restrictor. Okay. Yeah. So, so this is step one, step two, step three, step four. Okay. Step five is we need to calculate stiffness, the bearing flow rate, pumping power, friction power, total power. So if you need to design your refrigerator for the cooling unit in your power supply system, so then you need to calculate the total power. And then the final step is to design the restrictor. So for the capillary restrictor, it's a capillary diameter and capillary length. Okay, for small bearing, usually we, I mean, what I said small is means it means the dimension is small. So usually we select the capillary diameter, inner diameter point 0.2 or point 0.3. And then in that case, you need to cut certain length so that the well, we can have a look for the restrictor design flow control device here. So the rho is equal to the vibration minus recess ratio. And this is the diameter, inner diameter of the capillary tube. And this is the length of the tube. And then the viscosity So this is the capillary restrictor we use. Okay. Another type is that so this is a capillary restrictor. So we need to select the inner diameter and appropriate length for that. So usually if the bearing is small, the inner diameter is small. If the bearing is big, the inner diameter will be big. Okay. And for the Olympus restrictor, usually we select this one. So uh, if you search in the internet site or the eBay, you can buy one from United States. It's quite cheap for that. They are selling this Olympus restrictor by kilo. Okay, so you can select you can choose the Olympus restrictor with some certain inner diameter, C0. Okay. So in practical, usually we manufacture this Olympus restrictor without drilling the hole. Okay. So in the final step, depending on the requirement, we will decide what diameter this hole should be made. Okay. So yeah. In this case, we know the PS, we know the PR, and we know the density of the lubricant, and then we know the CD, the discharge coefficient, and we can calculate the volume flow rate of the Olympus restriction. Right. This is the case for zero or low speed uh, hydrostatic bearing. For aerostatic bearing is the same, but we have a slightly different. The procedure is basically the same. So give you some remind. So it should remain the same. So the pressure ratio is in between the range of zero point 0.4 to zero point 0.7 pressure ratio. Yeah. negative or that? Okay. So this is a pressure ratio for the hydrostatic bearing. The symbol is the notation for the pressure ratio for hydrostatic bearing is beta. For air bearing, it's called the KGO. Yeah. So this is the range of that, point 0.4 to point 0.7. So the tolerance for the film thickness, usually we are giving give you, we give you the upper bound or lower bound, similar to the low speed battery here. Okay. So the upper bound equal to the lower bound multiplied by 1.5. Okay. You need to check the final film thickness very carefully because it may change all your bearing performance. Okay. So according to the final film thickness, after the assembly, you will make some adjustment for your pressure ratio. So for the high speed bearing, which means the power ratio K, friction power divided by pumping power, greater than 3 or bigger than 3, it's called high speed hydrostatic bearing. But actually, this is a film, this is the design procedure for that. So we have two different flow charts. One is for the opposite path thrust bearing. The other one is for the high speed Jordan bearing. Okay. So this one is for the high speed thrust bearing. This one, the right hand side is for the Jordan bearing. It's more or less the same, but yeah, we have a slightly different for calculation for the film thickness. design lubricant or lubricant, but usually the viscosity grade of the lubricant. Usually the viscosity grade of the lubricant is not by calculation. I mean, it's not selected by calculation. Usually it's by taking reference from the similar product in the market. Okay? So you know more or less your size of the bearing, and you know your operational speed. Then you can make some reference from the commercial product on the market, and then you will know what kind of a lubricant they are choosing. Okay, so you can use that as your viscosity grade of lubricant, and you use that viscosity numbers to some estimation. So if it is fulfill your requirement, then you can use that one. Okay. And here is a kind of a formula you can also calculate design film thickness. Okay. But sometimes it's not the case. You should choose from your the assembly capability from your manufacturing factory. Usually you need to discuss with your manufacturing factory before you fabricate your hydrostatic bearing. Okay? So they will give you some of the reference number for your design film figures. 所以这边给了一个高速轴承计算的流程哦，那其实两个流程其实是差不多，只是说指挥轴承跟轴体轴承它们用的公式不太一样，所以这边的话我们可以去做计算，可能是年度，可能是它的设计间隙，但是年度一般我们通常大概不会用算，因为你大概知道你的轴承尺寸，还有你的工作条件，就是它操作的转速，所以通常我们就会去网络上查一下类似的产品，人家用什么组，就把那个油的年度号码带进去算算看。那另外一个的话，它是说，因为你完全如果不知道的话，你怎么去设计它的那个油墨间隙，这是一个方面。但通常如果我们这个方法算出来以后，你还是要去咨询一下你的加工厂，它有没有办法制造出来。它如果可以制造出来的话，就没有问题；如果是不行的话，要做一些调整。对。So usually it's one way to calculate your design build figure, but you still need to consult your manufacturing factory, see if they are capable to make some final assembly according to the design build figure. So when you look at the spec, so it's the same. First is select the bearing type, truss bearing or journal bearing, partial journal bearing or full journal bearing, or even conical bearing or spherical bearing. Okay. So and then you determine your invariable parameters or some requirement for your bearing, such as the load capacity or even the geometrical constraint for installation，或者是你的可能是它的承载力，可能是它的轴承安装的尺寸，可能有尺寸限制。And and also maybe you know about the supply pressure and the viscosity of your lubricant, or even some design film thickness and vary length with ratio. Okay. And then you calculate the value with the other parameters except the gradient or viscosity. Okay. So I can do some step, you know. Yeah. And you can the initial three step is the same as the low speed variable. Yeah. So there are some guidelines here. Okay. Design film thickness should be small, and length width ratio preferably should be 0.25. Okay. So the strategy is that you can reduce the length width ratio before increasing the film thickness. So when we design the bearing test area, in that chapter, there are some different ways to make some adjustments for the design parameters. So film thickness is very crucial design parameter. If you make some adjustments, that will affect your stiffness. So usually we should try to make some adjustments from other design parameters rather than to just change your film thickness. Okay? It's better not to change your film thickness arbitrarily. So in here, it says you should first try to reduce your language ratio before increasing your film thickness. There are some effects by reducing the language ratio by also increasing the film thickness. Okay. And then we have some limit for that. The low limit for the film thickness is that beta equals to 0.7. K is the power ratio for high speed stereo. And for the upper part of the film thickness is equal to 1.5 times the lower part. And beta is equal to 0.4. So here you can using this equation to calculate either the film thickness or the viscosity of the lubricant. Okay? If you predefine the lubricant, then you can calculate the film thickness. Or if you predefine the film thickness, then you can calculate the lubricant. And step 5 is to calculate the bearing performance. See if the thickness is suitable for your application or not. And then you can calculate the volume flow rate of your bearing and the total power for the bearing and maximum temperature rise for the bearing. Once these are done, and then you can design your flow restrictor. Yeah. For the design procedure of the high speed thermal barrier, and flow chart is the same, but the formula is different because it's for the thermal barrier. It's for the fast barrier. So, and the others are the same, exactly the same. So you can look at the page 121. So you can choose a bearing type. For example, the recessed general bearing. And the second step is that you can determine the parameters constrained by the machine design consideration. For example, the load capacity for your bearing and for the size for the installation geometry constraint for installation, okay? Diameter or length, or even the operational speed for your application. And the step three is that determine parameters that may be selected. Okay, the first one is length width ratio, A divided by L. So this one would be 0.25. Okay, and then we have an inter-recess length ratio, BOA, or length diameter ratio for joint bearing, L divided by D. And the next one is lower radial clearance limit, the design clearance limit, okay, or the pressure ratio, 0.7. So power ratio K equal to 3. And the step 4 is here for the determine the parameters to be calculated. So the first one is the supply pressure or the speed parameters, SH, or the viscosity, or even the clearance ratio, or the upper radial clearance limit. We look at the same page, page 121, and the step 5, to determine the performance data from chart or formula. For example, the bearing film thickness, lambda, the volume flow rate, Q, the pumping power, HP, the friction power, HS, the total power, HT, and the maximum temperature rise for one oil pad, delta T. Yeah. And then the final step is the design of your flow control device or design of your restrictor. So, so in page 122, for example, if you are choosing the capillary restrictor, is the diameter CC or capillary length, LC. And here we give you some of the reference for tolerance grade from the ISO standard. So this is for the this is called the international tolerance grade. So we have international tolerance grade IT3, IT4, IT5, IT6, 7, IT8. The smaller the number, the tighter the tolerance. The smaller the tolerance. Okay? Yeah. So this is millimeter, which means this is 10 micron for this one, 20 micron, 30, 40, 50, 60, 70 micron. Okay. For most of the hydrostatic bearing, it's in the category of IT3 to IT5. Okay. For hydrostatic bearing, so the tolerance grade is between IT3 to IT5. For air bearing, air bearings air bearings are even smaller. So usually they are in the tolerance IT3 and IT4. Okay. The smaller the tolerance grade, the production cost, higher the production cost. Okay. So usually, yeah, here we have some comments for what IT4. So for IT7, yeah. So IT7 is the average for precision machining, and IT4 is very good quality. Here we have some suggested clearance limits for hydrostatic and aerostatic bearing. So usually these tolerance will fall into the four categories: IT3, IT4, IT5, IT6. The film gap thickness, the upper bar, this is the lower bar. 这个是那个给的一个参考的建议，就是在一斤压或气压头它的设计间隙的话，通常的精度的公差的等级是在 IT3到 IT6。数字越小的话，就是越精密，通常都是制造成本越高。 question? For today's lecture. So, this is chapter 7, page 154. So this is exactly the design procedure for the single hydrostatic bearing type. So the good thing is for this version of the textbook give you some circular design procedure. So if you want to design a circular bearing type, just following the steps, 27 steps, so you can calculate all the bearing performance for that. Okay. And next week, I need you to bring your personal computer here, your laptop computer. You need to do the homework and to do the exercise for the table for the chapter 7. So chapter 7 we have six different no yes six different procedures. Yeah. For the trust bearing, I think for this chapter 7, yes. And for chapter 9, it's a Jonah bearing. You have one procedure to calculate the 120, 204. Yeah. This is the design procedure to calculate the hydrostatic Jonah bearing, recess Jonah bearing. This is for the low speed bearing. And for the high speed bearing, it's chapter 10. 232, I think. This is for the high speed Jonah bearing. The following step. The easiest way for you to do some estimation for the design of hydrostatic bearing is you just make it to a Excel table to do some estimation for the bearing performance. Okay. So you change this table into an Excel. So next week you need to practice in the classroom. So you need to bring your personal laptop computer. Is any problem for that? 所以下礼拜要带你的笔电来。So we will do the exercise of the classroom. Okay? So remember to bring your laptop computer here. On the classroom, we will give you each one of you one assignment to do. So you need to finish in the classroom and deliver to me. 所以你下礼拜要带笔电来。 课堂上会 so in the classroom, we will make a draw and see which one you need to do it. 所以我们会抽个签，看你做哪一题，下课就把那个交出来，Excel 交出来。So after the class, you need to submit your Excel file to me. Is there any question? 有没有任何问题？So you can have a look for the chapter 7, chapter 9, chapter 10 for the tabular design procedure. Okay. Yeah. It's not so difficult, just you need to check that. So I think it's similar to your assignment too. So you have one procedure A1 is the notation and the formula. And A2 is the numerical data. Numerical data, you can check the final results. 有没有什么问题？Any question for today's lecture? 没有的话，我们要下课。So this is today's lecture.